All right, students. So we've been talking about electrons, electron configurations, where the electrons go. So let's look at these three examples to talk about exactly where the electrons go with each different element and how that's written and what the different conventions are for that. So we're going to focus on these three elements. He, don't need to know the name, happens to be helium. This is exactly how it would appear on your periodic table, your trusty periodic table. So here you can verify that. That shows exactly how helium would appear on your periodic table, okay? And so on down the line. So we've got B is for boron, Cl happens to be for chlorine. All right, so our favorite and most important number, as always, with these guys, is their atomic number, which is written in bold for each of these. Let's make it a little bit more bold, okay? Nice and bold. Those are our atomic numbers, okay? So the atomic numbers, as we recall, tell us the number of protons. So we've continually, we consider balanced atoms, atoms with equal numbers of positive and negative charges, therefore equal numbers of protons and electrons. So each of these we can tell from its atomic number, not only its number of protons, but if it's balanced, its number of electrons. So that's right there on the periodic table for us. And we also have this curious number below 2. What's that about? 2-3. What's that about? 2-8-7. What's that about? Let's find out right now. Those happen to be the electron configurations. So let's pan out here and do the electron configurations of each of these. Let's do helium first. So we've got our nucleus, little dot. We know that we have got energy levels circling around each different nucleus. Helium has 2 electrons. Energy level 1, as we have learned, contains 2 electrons. So this is the energy level diagram with electrons for helium. Another way to write that is just to write for each energy level. So for each energy level 1, 2, 3, just write down the number of electrons. Energy level 1, 2, energy level 2, 0, because there's none. Energy level 3, 0. So we have just invented a new convention for how to demonstrate the electron configuration for helium. 2-0-0, or scientists don't always feel the need to write those zeros. They just write a 2, as appears right here. That happens to be the little 2. It's not very clear. The 2 right here is the electron configuration. The small 2 below the big 2 is the electron configuration for helium. Okay? Let's move on to the next one. B. We can tell from the atomic number, it's 5, it therefore has 5 protons. It's balanced, it therefore has 5 electrons. Let's start drawing B. Here's our nucleus, energy level 1, energy level 2, and let's fill in the electrons. 1, 2, and you can do 3, 4, 5, but I like to spread them out. Let's do it that way for now. There's our electrons for boron, energy level 1, energy level 2. So let's draw our convention for how else to write that. For a little chart, energy level. Oh, somebody's trying to come in. 1, 2, 3. Boom, boom, boom. 2 and energy level 1. 1, 2, 3, and energy level 2. And we'll leave off the 0. Well, in a minute we'll leave it off. 0 energy level 3. So 2-3 is the electron configuration for boron. Let's put a B here. Let's put an HE here. And that fits. We see 2-3 as the electron configuration for boron. Let's do another one. Chlorine. Here's our nucleus. Energy level 1. We're going to need all 3 this time. Energy level 2 and energy level 3. Energy level 1, 1, 2. We know that energy level 2 can hold 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we still need 7 more electrons. 11, 12, 13, 14, 15, 16, 17. So back to our diagram, just like this guy over here. Energy level, 1, 2, 3. Energy level 1 has 2. And notice that's a recurring theme. Pretty much everyone has 2 in energy level 1. But anyway, except for hydrogen. Let's keep going here. Energy level 2 has all 8. And energy level 3 has 1, 2, 3, 4, 5, 6, 7. So that is another way to draw, let's put it, we'll make it show the 7, to write the electron configuration for chlorine, for one of the elements. 2, 8, 7. And we see that right here, 2, 8, 7. So that's what those numbers are about. Those are the electron configurations of each of the different elements when they are balanced. So they show when it has equal numbers of electrons and protons. And that's just a simple way to draw the same thing that we see in the diagrams, only it's a lot easier to draw 2, 8, 7 than to start drawing circles all over.